Hello everyone and welcome to another 3D Buzz MMO research and development video. Yeah, that sounds good. So we're going to pick back up from the last video where Lee had put together his very basic test framework that he likes to work with when testing out different features, different R&D scenarios where there's a lot of things that he wants in place every single time. And this can become more and more important as we progress forward and we have the sound system, the effects system, etc., and have those all added into this test bed as features, just so that, you know, if we're testing out a new spell and we need to take advantage of effects and sound, it's just all right there. And as I said in the last video, Lee doesn't have to work in the massive code base of the MMO to test out very specific things. Now, one of the things that we've been talking about quite a bit recently is terrain and world size.
Right.
And as I said in the last video, this is kind of Lee's world here when it comes to terrain. He's done a bunch of terrain work in UDK and the old Unreal, and he's done a lot of terrain work in Unity. And you know, we're discussing some large worlds. We're discussing some unique feature sets that we would like to do, if possible. And some of these things, it might not be very feasible to pull off using the terrain engine that is provided to us inside of Unity. So I set Lee out the other day on a little R&D mission with terrain, just looking at different options. And he's going to spend a little bit of time not only letting you guys know what he's been playing with, but also me, because I'm just as in the dark as all of you guys out there. Some of the things that I told Lee that would be nice to have: one, massive worlds. You know, we really like some large worlds.
Well, you didn't say massive. You said you wanted to go in every direction forever.
Okay, so that's massive, which I'm glad you said that, Lee, because I got to remind those that may have skipped the last video, and I'm going to probably say this in the next few videos, then I'll finally get away from saying it, and that is these videos, the MMO class, are not going to be like any other videos that we've done with 3D Buzz before, because these are, again, just straight from the hip. There, I'm sure, will be mistakes and rewrites, and even in R&Ding stuff. Or sometimes we just, you know, Lee may show a technique here that he may later on go, wow, what was I thinking? This is a much better way to do it here. The bottom line is this is kind of like real world work, and I mean, I'm sure there's some of you out there that are absolutely slick where you don't make any mistakes. Unfortunately, that's not us. I know I'm really good at making mistakes constantly, especially when I'm trying to talk and type. And since these videos are just being shot from the hip, as I like to say, and we're not going to re-record if we make a mistake, that means we may get into arguments, we may debate something, who knows, but we're just going to capture it all. We've said that from the beginning. All right, so back to what I was interested in, massive worlds. And then I told Lee, wouldn't it be interesting if we had our own build of the MMO that acted as an editor, if we had people that were willing to help out with working on terrains, not just necessarily sculpting out terrains, but also getting in there and painting on the terrains as well. But imagine if you had a large zone and we brought in 2, 3, 4 people at the same time in different locations around the world to help work on a given terrain. Lee kind of laughed at me and said, well, Unity's not set up to work that way. And I said, okay, well, find a way to make it happen. So now that gets us into our discussion. So you're thinking that that ability might be something that you can pull off?
Yeah, I think I can.
Okay.
I can't do it with Unity's built-in terrain system, though. But that also falls back to another one of the requirements that you gave me. You wanted to be able to also have potential to take the data for the worlds that we have in these land masses, terrains, and be able to use them in a mobile device.
That's true. That's I didn't mention that one, but I guess we can let them in on everything we're just playing with. And doesn't work out too well if we want to use the built-in terrain on, say, an iOS device, does it?
No, not at all. Seems how you don't even have that ability. So right there that goes, oh, well, terrains are out, or built-in terrains are out the window. Now, there are a couple of different ways that I started looking at doing terrains. You've got the old stand-in, which is based off of a height map. You also have the ability to build a a mesh, your terrain mesh in an external application, and import that in. And that has its benefits and limitations.
And if I recall back in the tech demo, what app was it that you were using?
I use a little application that's called L3DT Pro.
Right.
And I like it because it's fairly cheap. I think when I bought it was about $50. I'm not sure the exact price of it nowadays. But it has a really nice feature that I like. And in the case of one of the possible ways that we can go with the terrain, you can define an absolutely huge map, and then you can break it down into little chunks, and it will save those chunks out as individual files.
Okay.
So they all tile up and match up again.
Gotcha.
Which in this case, if we were to build patch terrains and tile them, works perfectly.
Okay.
So,
and that does allow us to get away from, well, first of all, when dealing with the built-in terrain, you said we can't use that on the iOS devices. But it also results in a massive number of draw calls, all right?
The terrain system?
Yeah,
yes.
The terrain system in Unity.
Depending on the size of the terrain, width and height, width, height, and depth that you use, as well as all the resolutions that you use for your splat maps and texture maps, can cause an excessive number of draw calls. I think in our platform game, I was getting in excess of 1,000 draw calls, and it wasn't very optimized at all.
And for those of you that have never worked with an iOS game that was created with Unity, actually doesn't matter where it was created, one of the things that you're constantly doing is making sure that you keep a very low draw call count. You don't want to be sending off a ton of stuff and a lot of draw calls to get drawn and processed, because it will basically bring your game to its knees, slow you way down. So something like 1,000 draw calls, no, we're not going to be able to get away with something like that on an iOS device. Right. So now what you're talking about is generating terrain inside of Unity. So we're looking at creating meshes and handling them as patches, where we only bring in the patches that are absolutely necessary at the time from where you're standing.
Right. One of the experiments we did first was testing the ability of using like L3DT, exporting a raw map, bringing it into a package like Maya, building a mesh from that, and then bringing that mesh in.
I remember that.
But that doesn't meet the requirements of being able to edit it too well inside of Unity. Now, the way you look at it is we've decided it's going to be a height map based world or mesh that we end up with. So there's a couple of different ways you can do. You can do equally spaced grids when you're looking at height maps and just sample from a height map and then you displace your grid that way. Or you can do basically take your grid, and in an exterior package like Maya, you can concentrate all of your vertices to where the detail needs to be and use less vertices in large flat areas.
Right.
Now, that has its advantages and disadvantages. The advantage is you're optimizing your vertices, which is great. But now you're pretty much relying on a 3D package to build your worlds, and then they all the patches have to be perfectly aligned on the edges and brought into Unity, which gets you a static world. So that idea pretty much went out the window when we decided that we want to be able to have multiple people working inside of a Unity tool that we build. Basically, it's just a game that we modify as a tool.
So instead of saying to people out there that are volunteering in the MMO class to help us out with, like, say, terrain construction, we don't have to say, oh, you've got to have Maya to be able to do this, or some other tool. We could actually put multiple people in the world in this zone or whatever we end up calling it,
right.
And somebody could be on one end constructing something and somebody could be on the other end constructing something. Okay?
So now, we've decided we're going to build our message procedurally inside of Unity.
Okay.
Now, one of the other projects that some of you guys may have been following, I've been playing with creating meshes on the fly. So it's a fairly easy process once you get the hang of it. So that's what we've decided to do. We're gonna do some experiments with creating the meshes inside of it dispersing the vertices and then taking a height map to displace those vertices to give us a three-dimensional world made up of patches.
Okay.
Now, these patches, eventually, we'll be able to tile those, and we might even look at some level of detail type calculations in the future where we can have higher res meshes up close to where the person is, and the further away from the camera we go, the less resolution that we use.
Okay.
Now, when we use procedural or we import our meshes from an external application, there is a hard limit. That hard limit is 65,000 vertices. That's the most that Unity will allow. And I don't
now, is that per mesh or
per mesh?
Okay.
So now that limit, I believe, isn't even really a Unity. It's an OpenGL limit that we're kind of stuck with. So we can't really go above it. So that means when we're bringing in our or making our meshes, we've got to keep that in mind. We can't just go, well, you know, I want 1,000 by 1,000, which is going to give us an insane amount of vertices. That just won't work.
Okay.
Unity will error out, and it won't crash, but it just won't let you do it.
Okay.
So we want to keep our meshes smaller than 65,000. Now, another consideration that, based on what we've been discussing, with the ability to collaboratively edit these, means that the data for these meshes are going to have to be transmitted across the network in some fashion. So the other the other thing we have to keep in mind is we've got to keep the amount of information that is getting sent via updates as small as we possibly can. So we want to keep our terrain patches small enough that that information is not going to overwhelm the network, but large enough that gives us a sense of a large piece of terrain.
You know, I just sitting here thinking about this. Again, since we can take all the time in the world, ladies and gentlemen, because an MMO development process is not going to be super fast. So yeah, there. Thinking about it, at least. So that means another thing that I could start looking at soon, because I'm more into the networking side of things, and Lee's more into the graphics programming side of things. I guess it wouldn't be a bad idea to get Photon going. I mean, I figured this week you're going to be R&Ding your butt off with all of this stuff, because getting all of the seaming stuff in place is going to be important. And then somewhere not too far off, I would assume possibly later this week, it would be nice to get a very basic proof of concept running that has networking in place, so that we can see if you and I can both edit, just push and pull and smooth some vertices in the world together, which means to have that networking in place. Since we're using Photon, it wouldn't be a bad idea for me to get that up and running just as a whole. This isn't the MMO game. This is just, again, a proof of concept. But the cool thing, I'm just thinking out loud for our viewers out there, is when you're working with Photon, you have two different routes that you can take. You can take the I'm just going to call it the light game route, or you can take the MMO route. And with light game, that's really about making games where you've got a lobby you can go into, then you can join into a specific game, and it's not an MMO interest management type scenario. That's why they have the whole MMO side of Photon that you can take advantage of when working with MMOs, so that all of the interest management stuff is already in place for you. But thinking about it, Lee, we could use light game and take that angle. The nice thing is, for our viewers out there, I do know that we have some people in the class that don't have a desire to make Unity games, or Unity, haha, my bad, to make MMO games, but they're very interested in making networked games. And by doing this, we could give them an exposure to the light game side of things, because later on we're going to be spending a significant amount of time in the MMO side. So that lets them kind of see, everything that's available with Photon, and that should work out pretty well.
It should, yeah.
Yeah.
We just need a central, and on top of that, we'll need some place that's central to save all of these little height maps for each one of the patches.
I need to get a hold of Nelson. Tonight would be ideal, sooner the better, because you're going to be flying home in just a little while. But it would be great to get a hold of Nelson and have him start teaching me a little bit about Raven DB.
See if we can tie that in.
Yeah, I know very, very little about it, because I've just been a relational database guy for forever. And since he's wanting to take this new angle, I told him, we'll explore it. We'll entertain, your thoughts, and we'll see. So maybe later tonight I can get a hold of him for some basic lessons there. And while I'm getting these lessons, I'll make sure to record them for our members out there. Yeah. Okay, so.
Well, we're going to make little terrain patches.
Okay.
So a terrain patch is going to be a mesh. A mesh is basically an array of vertices. It's also... To make a Unity mesh, or pretty much most OpenGL meshes, you need an array of vertices, you need an array of UVs for mapping your textures to those vertices, and you need an array of triangles, which is a list of which vertices make up a triangle.
Okay.
Now, that is going to be a clockwise wound list. So basically you pick your vertices in an order that go around clockwise, and we'll get into that when I start showing you how to create the mesh.
The reason of that is for determining your face normal?
Yes. Well, determining what is considered the front of the face and the back of the face.
Exactly.
Pretty much all of the built-in Unity shaders are single-sided shaders.
Right, so they're going to only render on the
front side.
That's
so if you start playing with meshes and you're pretty sure you did it right and you're not seeing anything, move your camera around. You might have wound your stuff backwards.
Okay.
So, and you've seen that if you've experimented with the built-in plane inside of Unity, where one side you can see it, you rotate around, it disappears.
Right.
Same thing with these meshes. If you rotate behind them, they're going to disappear.
So in this video, outside of just giving a quick overview of what it is that we're shooting for just in the R&D session, now you're wanting to explain a little bit about the mesh, and then when we get over into Unity, well, that could even be in the next video, I guess. Then you're just going to start very simple.
Right.
And work your way up.
Right, because what I want to do is I want to explain why I chose the vertice layout that I did for this particular mesh.
Okay.
Because there's many, many different ways you can lay out your vertices.
Okay.
So, but I chose one way in particular for a certain reason. I want to show some of the different ways you can do it and why I chose the way I did. So I've got Photoshop open. So I've already done a couple of slides so we can show you the different layouts. I want to discuss that, and then in the next video I want to jump into Unity, and then I want to start simply by creating the most basic grid and adding more features so we can start simply and iteratively get to the vertice layout that we're going to demonstrate here.
Okay, awesome.
So when you're looking at your mesh, a patch is going to be square. We're just simply going to say our patches are square. Makes sense if we're going to tile them.
Mm-hmm.
So the simplest way that you can lay out a patch that is square is going to be with a bunch of little squares. So if we're to look at this as each one of these quads is a face, then we've got a 4x4 grid or 16 faces. Now, the way Unity works is it works based off of triangles. So each one of these faces has to be split into 2 triangles. Now, one of the easiest ways to do it mathematically, and I wish I could do it, would be to just diagonally split each one of these, and we would start.
You say you wish you could do it?
Well, I can do it. I wish I could do it and have it look good.
Oh, okay.
Let me clarify that. Thank you. But basically, we would take each one of these intersections being a vertice, and we would pick one and go, okay, this was the first one of the triangle, then here, and then here. This would fill in this triangle.
But it seems to me that, let's say that's, of course, you've got all these triangles filled in, and then you picked a point in the center, and you pulled it up. I'm saying a point in the center of the whole grid.
Oh, here?
Yeah.
Oh, yeah.
And you pulled that up.
Right.
You're going to have some
very interesting artifacts here. Depending on when you start pulling it, it's not going to split very nicely. Actually, I could draw it this way. You're not going to get a nice split this way. It just can't do it.
Right, because we're only going to fold around, all of the edges.
Right. So the only way that this will look well is if this point and this point are always higher than these 2 points or always lower than those 2 points. So that gets into a very interesting problem if we wanted to pull the point in the center up. It's just not going to look right. So one of the ways that we can do it is use an alternating pattern. So now we could pull in the center up.
Yep, I can visualize that.
And then as we pull more and more, if we had a soft selection, we could pull up in the center, and then these two would start to come up slower, and it would crease here, here, and here. And if we pulled further, then it would crease here, 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 and here. And what you get is a pyramid effect. And you've probably seen some older games where everything looked like little pyramids as it was coming up. Better than the first one.
Still not ideal.
Still not the best.
Okay.
So, and you could come up with many different solutions for dividing up this way. I mean, you could do a herringbone, but what I decided on instead is something that's hexagonal. So if I do it this way, now if we pull up in the center, instead of getting a pyramid, we get a six-sided. It looks a little bit more rounded. And as we pull further and further away, we're getting more vertices aligned from that center point to make it...
They can't see your hands.
Yes, my hands are working furiously.
Yes, they are.
But it gives you a smoother result that looks more like a mound than...
More like a mound than a pyramid.
Exactly.
Okay.
And you don't get as much creasing.
Okay.
Now, to pull this off, we still have our underlying patches. But the way we're dividing them is we're dividing each one into thirds.
Gotcha.
Now, the way it works is, in essence, we're offsetting our points by 1/2 and then adding another one. And when I get into arranging the grid, we'll see this in code and how it works. Because what will end up happening is you'll have, in this case, a row of 5 vertices, a row of 6 vertices, 5, and then 6, and then 5.
Okay.
So, but what we're going to do is we're going to take all of the rows that have 6 vertices, and we're going to compress the outside ones to conform to force them to stay in this square.
Okay.
And then we'll go through some more calculations to determine the winding for each one of these triangles. And then once we've got those triangles laid out, they'll become meshes. We'll calculate their UVs. We'll apply a texture to them, and then we can turn it into a 3-dimensional terrain instead of a flat grid.
Awesome.
So,
and even then, but before we turn it into a 3-dimensional terrain, it's just going to be a 3-dimensional flat grid is what we're going for starters, right?
Yes.
Okay.
Yeah, the next video we're going to work on getting a flat grid that represents this. And instead of having lines, what I'm going to do is put little spheres at each one of these vertices.
Okay.
And I'm going to show you how the grid's laid out. And once we know that the spheres are located where the vertices, or where we think the vertices are, we can visually see to make sure that the code we put in place is doing what we think it should be doing.
Okay.
And then once we verified that all the vertices are in place, then we'll come back in a video after that, and we'll start laying down our meshes.
Start generating the actual meshes.
Yep.
Okay, fantastic. Numbering, was that anything of importance there?
Well, I'll show it. I'm gonna bring it up again once we get to building the mesh, because this dictates how our vertices are going to be calculated. Basically, we're going to number from the lower left up to the upper right, and this is the way the vertices will be calculated, put down, and then we're going to use these numbers to determine how we're going to calculate the winding. And I'll cover that a little bit more in the future video, because the winding has 4 different variations that we're going to have to go through.
Based off of location in the mesh generation?
Well, it's going to all determine whether or not the row we're doing is an even or an odd row.
Gotcha. Which is where you are within the mesh.
Yes.
Yeah. Okay, fantastic. So is this pretty much it that you want to say for kind of getting us into?
Yep. And for this video, that's all I want to say.
It's just a reminder. This is just R&D stuff, guys. So we're playing with stuff that could end up being thrown away, or stuff that could end up inspiring and growing us into something that's absolutely awesome. But everything that is being done here, I figured, could be valuable to different ones of you out there for different reasons. That's why we're grabbing this stuff. So thanks a lot, guys, and we'll see you in the next video.